Okay, so this is a report, and this is, you guys are familiar with how LaTeX works. This is a different template from the one that was used in ENR 200, but this is a template that you should use for your report that you produce, and you should be using this as a guide for how you should construct your report, okay? You can include data in tables if that is appropriate. You can include code using color boxes, okay? That's something else that you can do. And so you should have the header set up this way using the engineering logo and having the information about the class and your name and other stuff that's in there. And then you have plots. If you want to put in a new plot, you can put it in like this. So there's all kinds of information in the text file that will help you to construct the report that you're going to write, okay? If you want to put references in, you can do that as well. So does anybody have any questions on how to make this work? No? Okay. Alrighty. Okay, so let me go back now and talk a little bit more about this assignment. So I put in here how the points are going to be broken down, okay? You're going to be collecting data, right? And you're going to graph it and write a report about the process that you undertook. When you decide what you're going to collect the temperature data for, make sure that it's not just, well, I put it in my room and let it go. Okay, it has to be something a little bit more interesting than that, all right? That's something that you and your partner or partners will need to decide what you want to do, okay? You're going to need to include, when you're going to have to put together all the files that you need to produce the report. That would be your data files, your graphs, okay, and any scripts that you have that you've completed. And then you only want to include code using technology from this course, okay? Please do not be tempted to use ChatGPT or some other AI to produce code. You need to do it yourself. I will tell you that going forward, you're going to need to be able to do this for other classes as well, okay? And so if you're relying on AI, you're not going to be able to do the assignments that you need to do even after this, right? So please do the work yourself. Work with your partner. If you're struggling, you can come and talk to me about your difficulty with your code, okay? So you want to have a scientific goal or reason for measuring the temperature. Okay, so think about what you could measure the temperature of that would be interesting. All right. Then when it comes time for you to submit the report, you're going to want to take it, and this is how you can bundle all of the files together using tar. Okay, with these flags. You're going to want to put your own last name and first name in here. Now, the expectation is that you and your partner or partners will submit the same documents, but it should be that it's in your name, okay? So when you set things up, you put yourself as the author, right? And it should be that you submit the same stuff, though, okay? Now, you upload to Canvas. The due date is the 22nd of April at midnight, okay? So that's coming up after Easter. It's during finals week. Now, when you upload your submission, okay, in your own name, one of the things that you're going to need to do is in the comment box, you need to type in the parts that you're responsible for this project, okay? It could be that you were the person who did this part, you were the person that did that part, or you did this with their partner where the two of you did it together. The other person did this other thing. So indicate what parts are yours, what parts are the other person in your partnership, and then what stuff you did together jointly, okay? Like, I want to know that, and I want both people to submit this, and what you submit should be different, okay? Like, what you tell me, I don't want to get it that I get two partners and they type exactly the same thing, all right? It has to be your comments. What I'm looking for is that it is a true team and partnership that both people contribute, okay? And I want you to be candid about this, all right?
You just want that in the add comment?
Yes, in the comment box, right. Yes, that's where you would indicate to me. Like if you, and it's definitely confidential. Don't worry that, somehow it's going to get back to your partner that you ratted them out, that they didn't do anything, okay, don't worry. You can blame me for whatever happens. If you get a good grade and they don't, you can say, I don't know, man, it's her, I don't know, right? So that's fine, okay? You can definitely blame me if the person, receives a lower grade because they didn't participate, okay? But I would hope that you will work together well, all right? If you're having trouble, like the other person is not responding to your emails, texts, whatever, I would also say please contact me about that, okay? All right, does anybody have any questions on this project? Not so far, right? All right. Okay, so now it's time to talk about using the Arduino. Okay, so let's go down here. Oops, I need to get rid of this. What is going on here? I don't know why I'm seeing this. This is weird. Okay. Okay, anyway, let's go over here. All right. Okay, so first of all, let's talk about let's recall what happened in the previous class, CNR 200, right? How we worked with the Arduino, right? And I know some of you went and got your kits. That's very nice that you did that. I'm very pleased to hear that. But your team was going to receive a kit, okay? So if it turns out that you're sitting now and you have 2 kits, that's fine. As many people do this as possible, okay? I sat through an earlier class today, and there was 1 kit for each pair of people, and only 1 person got to actually work with the hardware that way. It's better if you both do, okay? So let's talk about what's going to happen now. We want to open up the IDE. So you can get to that by typing Arduino ampersand, okay? And you remember this? Okay, you remember doing this? What I'm going to do now is I'm going to close this one. Close. Oops, it just closed me right down. That's not what I wanted. Okay, let me go back to this again. Ampersand, back up. Okay, there we go. I want to do new. Okay, here we go. Let me close down the other one that I have. All right. So if you open up a new one, you're going to find that it probably says sketch _ April 10th, right? So what we want to do now is go ahead and save this as it is, even though it's just the template for writing a sketch, right? So just go ahead and save. Okay, and then go to the default. Notice where it is. It's under Student Arduino, right? Okay, so let's go over here now to the terminal window. And I'm going to do CD Arduino. Okay, and I'm going to do ls. And then I see that there is a directory in there called sketch. I would like to move the sketch April and then to, I want to call this LED1, okay? And if I put the / afterwards, it works, which is nice, okay? So if I look again, I now have a directory called LED1. And if I go down into LED1, I see that I still have that sketch in there, but I want to move that and call the sketch that's there LED1.ino. Okay. Okay. So let's go in now. Actually, it might be a good thing for you guys to take your Arduino and mount it on the board. Okay, if you recall how to do this, you want to set it up so that the end that's got the port for the USB, the mini USB cable, is at one end, okay? And you want to mount it so that it straddles the non-conducting channel, right? Remember how to do this? You put the connector point up here. Okay, like this. Okay. And then you're going to want to, and push it down. Does anybody need any assistance with this? You guys? Okay, and then you should plug it into one of the USB ports on your computer. And I'm delighted to find that I can still operate my mouse and the dongle and my Arduino. I have enough ports for that. That's awesome. Okay. So you should be able to plug it in and see the red light glowing on top of the board. Okay. So once you have that, you're going to want to look up here and check to see, let's check to see under Tools what port you're connected to. So probably you're going to find it's /dev/tty USB 0. Okay, that's usually what it is. Okay, and then your bootloader. Okay, so the bootloader, that's the processor, right? You see above that what processor you have? So the one that there are 3 different options. It's either, your board is going to work either for AT Mega 328p or 328p old bootloader. So mine is on old bootloader, and what I was told earlier, and which seemed to be true, we're just doing like a informal kind of analysis of this, is if you look at your Arduino and you look at the color of the connector, the place where you connect the USB cable, if it's gold, it probably means that the old bootloader is the one that you should have. Gold and old go together, okay? And if you have silver, then maybe you're supposed to have the newer bootloader. So that's something we're not sure about, but we think that might be the case. So old, if you have gold, then try old, okay?
Should we switch if we have silver then?
That's what we're speculating. We're not absolutely sure, so we'll see if yours works, okay? And if it doesn't, then we'll switch to the other one, right? Does that make sense? Yeah, okay. All right, so we're going to, we've now seen this, okay, and we have this code set up, so it's led1.ino, okay? But now, rather than working with the sketch within the IDE, we're actually going to use Vim to do the editing. Okay, so let's go over here. We're in this directory now, which is LED1, right? So let's do Vim, and it's led1.ino. Okay, so we're in here. All right, so here we go. We're going to be doing some stuff here. So you remember what we did with this before, right? This is all going to come back to you if you don't remember right now. So I'm in insert mode. I'm going to hit, oops. Nope, I didn't insert mode. Okay, I'm just going to go like that. And then JK navigate up, okay, up, okay, and then go into insert mode. There we go. Okay. We're going to declare an integer variable, which is LED pin. Okay, and we're going to set that equal to 3. So we're going to be using digital pin 3, okay, during this activity. And then we're going to set up another variable that is a character variable. That's the type, and it's called command. So we're going to be specifying certain characters to try to control what happens with the Nano, okay? And now within the setup structure, let me go down JK, JJ. Okay, I'm going to go to the beginning, O, and then I'm going to go DD, because I don't need that comment, right? We're going to be using serial, the serial library, serial begin. Do you remember this? This is what we use to communicate with the Arduino before when we want to pass data or collect data, right? Before we just collected. We didn't use it to send anything, right? So now we're going to be using it to send stuff. We had to put a semicolon at the end, all right, because this is the language that's understood by the Arduino. It's a dialect of C++, okay? And then we go pin mode. This is in the setup, right? Remember this stuff? Okay, now the LED pin that we've declared, we want to make that an output pin. Okay? So that's all we want to do inside setup. Okay? JK, I'm going to go down, JJJ, J, and then I'm going to do O and DD, because I don't need that comment. Okay? Within the loop, okay, we're going to use another function from serial. If, okay, the if structure. Now for Arduino, we use parentheses for if. If serial, notice serial is capitalized, available. This is not one that we used before. Serial available, okay. If that is greater than 0, then, okay, so it's going to check to see what that function returns, okay. Command equals serial read. You know, we use serial write and serial begin. Remember that? Okay, but now we're using serial read, serial available. This is other stuff that we need to be able to do what we want to do. Okay, so we're going to be checking, basically we're going to be inputting a character from our keyboard. Okay, and that's going to be read, and whatever we input from the keyboard, the variable command will be set equal to that. Okay, so here's how we do it. We say if command equals, okay, 1. Now notice I put single quotes around 1. That means the character 1, the key 1 on the keyboard, okay? If it's 1, then what we're going to do is digital write LED pin high. What we want to do is turn on a light, okay? So when you hit the 1 key, we should turn on a light, okay? Okay, and then we're going to close out that loop. Now we're going to put in another one because we might want to type something else, okay? If the command instead, the key that we hit is 0, okay, we're going to do digital write LED pin low. Turn off the light, okay? In fact, I'll put a comment in here, turn off light. Okay, I'm going to go up, JK, KK, K, K, then go down, J, okay, and then go to the end, A, and then I'm going to put a turn on light, okay? JK, go down, JJJ, and then go A, all right, and then we're going to close out this if statement, okay? So we have 2 ifs in a row right now, okay? We're going to put in another one last one. If command equals Q. Now we're just going to stick with lowercase q, all right? Keep it simple, all right? Then we want to do serial end. Okay, and we put open and close paren, okay? And then after that, set up like that, okay? And then we close this one out. So what we have now is this if statement. If the key that is pushed is 1, this if statement if the key that's pushed is 0, and this if statement if the key that's pushed is Q. Okay? We have, yes?
Did you forget to close out the first if statement?
Yeah, I'm not done yet. You're right. You're absolutely right. So I was going to say, we have this first if statement here, which is if the serial port is available, and we haven't closed it out yet, okay, which we have to do now. Thank you. Right there. Okay, and so we have the second parenthesis down here. That's to take care of this overall if structure. The third parenthesis down here is for void loop. Okay, that closes that out. All right, so that's why you have to have 3 parens in a row at the bottom. And that should do it. Okay, so now I'm going to do JK to get out of insert mode. I'm going to write the file, and I'm going to leave it up here in case you would like to refer to it. So there we go. And so now what I would like to do is I would like to open this file within the IDE. Okay, I'm going to open the file. So let's see if I can find it. Open, where is it? Arduino. Okay, it's in LED1, right? Inside there is the LED1.ino. Okay, so now I've opened it. I want to close the other sketch while I'm at it. Hang on, I'm going to just close this guy down. So this is the one. There it is, right next to here. Okay. So what I'm going to do, oops, we now have to set up, your circuit, right? I keep talking about LEDs, right? So this is what you got to do to your circuit. You're going to want to, okay, you've got to identify pin D3, right? Remember D3? Okay, so when you look at the connector's here, right? And here's your cable, right? Your USB mini cable is up here. Okay, then D3 is down here, right? D3. Okay, you're going to want to connect that to a resistor. Now, we're using 270 ohm resistors now, right, Rodrigo?
Yeah.
Right, so the 270 ohm resistor, when you pull out these resistors, you got to find the one that's 270. 270 has a red stripe. It's got red, purple, brown, and then I think gold, okay? I hope this is all coming back to you. 2, 7. This is 10 to the first because brown is 1, and then this is plus or minus 5%, okay? So you need to find the one that's got red, purple, brown, gold, okay? So when you connect, what you're going to want to do is connect your resistor at pin D3. Okay, so you remember how to do that? You have to put it in one of the holes that's right beside D3. Okay, and then you run the other leg needs to go into a different row, because if you put it in the same row, I would put it actually out to the side, along the side where you have the rail that's marked with red, right? That's where I would put it. So it has no chance of being connected inadvertently to some other pin, okay? But you know how out here you have this plus rail? That's where I would stick this. Personally, okay? If you're comfortable putting it together yourself, fine, okay? But this I'm just suggesting that if you don't really quite remember what to do. Now, that resistor, you're going to want to connect that to the LED. So that means the long leg of the LED needs to go into the same node as the resistor, okay? So then the LED long leg, okay, I'll make it bent, okay? And then the short leg needs to go into some other row, okay, some other node. And then from that row, you need to run a wire to ground. Okay, so the circuit looks like this. You've got your Nano, okay, D3 here, connected to the 270 ohm resistor, connected to the LED, and then goes over to ground. And I'm happy to look at anybody's circuit if they want me to, okay?
Red or blue, green doesn't matter. Okay.
What color for, I'm sorry, LED, anyone you want.
Okay.
That's a design choice. Okay. 270, so it's red,
270.
purple, brown, and then a gold. So there should be 4 stripes on the resistor, okay? Yeah, it's R. Did you actually have words on yours? Because the one I have is just a little piece of tape with no words. But yeah, if you have a piece of tape that has 270R, that's the correct one, okay? But verify when you look at the stripes to make sure it's the right one, okay? Anybody need any assistance?
I don't think we have.
Yeah.
Oh, you. I can
I just have 153.36.
Everything is pushed.
Okay, the important stuff, that's that, right? Yeah.
Yeah,
Okay.
like the resistor is only to control the current, so one's gonna be brighter than the other one. Yeah, some are
Okay.
220 instead of 270.
Oh, are they? Okay.
Oh, they're okay.
I didn't realize that.
Anything that has like a third strip brown would work for you.
Okay, so 220, that would be red, right? So 220 is red, brown, and then probably it's gold after that, right?
So 220 I would with?
220 is fine. Remember, we used 220 before.
Yeah.
I had just heard that we were out of 220s, and that's why everybody got 270s, but I didn't realize some people got 220s. The idea is that if you don't put a resistor in, then the current is too big. It's too big for the diode to handle, for the LED to handle. So you have to put the resistor in there to attenuate the current. It burns off some of the energy, right? Basically, that's what it is.
Yeah, I used to do that. Where? I have back home.
No, like the thing is like we don't have so like this is just the rail. So like I put something here. And I go here, I can put anything along this whole rail. It's gonna be the same. So it's just a way for you to, let's say you get the long breadboard, right? I want to connect something from here to the other side without actually having a long wire going through. So then you just use a rail. You know? So like for example this.
And then, I like to walk inside. And
So that's what so she
so then, whenever another pile of fireworks,
instead of going in the rail, you're just going to
Well, I mean,
what's happening?
where you can have.
Oh, so it's just along the whole way.
Yeah, so then therefore you can have it way down here instead of it being all bunched up there. Oh, I see.
yeah, so every time.
Also pretty similar to the new ones.
So it doesn't yeah, I guess that's right. At the same time, like if it's a variable that you know is a variable, it's gonna if it's not moving because he doesn't recognize it as a variable, so it's not gonna come in favor.
Wait, why'd you do it on?
I don't know, it's probably already going in one of the blink.
Yeah, sure.
Something like that.
Gotcha.
Really good.
I got some sweet LEDs for Christmas. Look at this.
For a long side.
I tried to move it to the Arduino, but it's so it had like really light. Yay!
Or gold brown too.
Actually, for LED, not this one.
Whoa, so I
Yeah, but you're just
Oh, that's a different.
no, you can connect this.
No, I did.
Really?
Yeah.
You guys too small, you can do like that.
Oh, I've seen that before.
Yes, so if you already typed, click on the check mark so you can see if your code has any syntax problems. Like if you missed any
Yes.
semicolon or if you mistyped something.
Yes, thank you. I'll go back to here and show my code again. Okay.
If you have a problem, you can raise
LED pin is not declared. Okay. Did you type? You have a typo?
Oh, this is like for voice
Yeah,
setup.
see, this is,
You want
you remember this stuff, right? Okay. This is the time to debug your code. So try, as Rodrigo said, to go ahead and click on the check mark, which will verify the code. It should check to make sure that it's okay, right? Wait a second, I have to do this O. No, not O, I want O, okay. JK? JK. Right? There we go. All right.
I think it's just the. But no, so I think.
It's the same code, right? No, like that. I just copied the
Yeah,
code
yeah.
and put it here.
Yeah. Without the. Yeah. Is that like? I don't know.
You didn't give me that problem. Yeah. No, things like that.
Okay.
Sometimes.
Have you all been able to upload your code? If you recall how to do that, you can upload it within the IDE. Just open it up in the IDE and use the arrow button, okay? And if you're having trouble with it, may mean that either you have a typo of some kind in your code or you are using the wrong bootloader.
Is anything supposed to happen?
Not yet. That's a good question, though.
I'm getting upload errors. It said invalid library found in /home student Arduino libraries.
There it is.
Invalid, so you typed exactly what we have here?
Yeah.
Are you sure? Rodrigo, would you mind looking at at Carl's stuff, because he's having
I mean,
problems?
I don't know if it's like rash, if it's necessary issue. But like when I hit upload, this is what I'm getting.
Oh, no, that's fine. If the uploading is
Okay, sweet.
Okay, now, we have to set up serial communication from the computer side also. We've set it up in this script, in this sketch, from the Arduino side, but we have to set it up from the other side too. And so I'm going to type something now. I invite you to type it as well. Okay, I'm going to do clear this because I want to show you. This is what you're going to need to type, okay? STTY space -F and then /dev/TTY USB. I assume you have USB 0. Does anybody not have USB 0? Okay. Hang on, I gotta just resize my window because I want to make sure that I get this in here correctly. Okay. And then 9600 is the baud rate. That's the bits per second that are transmitted. Okay. And then we have more stuff to type. So don't hit enter yet. Okay. -HUPCL. Okay. Space -echo. I better make this window even wider because there's more to type. And then we want to put CS8 space CREAD space. We're almost done. min 0 time 10. Okay, that's the whole thing. Hang on a second, let me just make this even wider. There we go. 10. That is what you need to type, okay? Okay? Now, if you get your prompt back again, then this is what you can type, okay? Echo 1, right? Type echo 1 and it should just print a 1 to the screen, right? Let me make this bigger so I can still show the command in case you need to look at it again, okay? Let's pipe that, well, or direct it, not pipe it, just direct it, okay? Echo 1 to dev TTY USB 0, okay? Enter.
Oh, it's on.
It's on, good. I was looking and thinking, why isn't mine on? It's because I have no light anymore. What happened to my light? I removed it. Okay, so your light, hopefully your light turned on when you did that. If it did, you can type this now. Let me go back here. 0, yep, and it should turn off. Okay, that's what's supposed to happen, okay? that is the goal, is to get that to work, okay?
So if
This
if
that's
you
all
here
you
to the
do.
on the arrow.
All right, are you able to do this, guys?
Yes. Yes.
Oh, isn't that awesome? Okay.
Arrow.
Mine did not work. How come mine didn't? Oh, wait. Mine worked before. There we go. Yay. Okay. All right. So, right. Okay. So this is kind of nice because this is bringing together some stuff that we did in a previous class into this stuff that we're doing now, right? It's kind of cool. All right. Okay. All right. So we're doing this in an interactive way right now, okay? So if you aren't at this point yet, I would invite you to just keep working, and both Dylan and Rodrigo can help you to get up to make sure that you can get this thing to work, okay? So you don't want to be walking out of here without this working, okay? Now, if you are ready, we're going to go on and write another script, okay? Yeah. Let's, because we want to automate all this, right? We'd like to automate it. So, so this next thing we're going to do, we're going to write another script, okay? This one is, I'm going to have to put it someplace else. Where am I going to put, yeah. I'm going to put this on my desktop now, so I'm going to go to desktop. Okay, we can write a script to automate all this stuff that we're doing now, all right? So let's see, what are we going to call this? I'm going to call it light, okay? So let's call this vim light.sh, okay? And I'm going to do insert and start typing. So shebang bin bash. Okay, the first thing we're going to do is we're going to have a variable called port. Okay, and we're setting it up as a variable in case you need to change this. Okay, so right now it's dev tty USB 0. Okay?
Yeah, I guess she's writing a script.
Okay, this is what I did. I navigated to my desktop. Okay, and now I'm making a script because everything we've done, we have a nice little sketch. Go to your desktop now, once you get this done. Okay, wait, are you on your desktop? Okay. The INO file is under the Arduino file structure, right? This is a script now where we're going to work with the Arduino directly, okay, because you know the scripts are nice to automate things. Yes?
What are we calling this script?
I called it light.sh, okay? That's what I'm calling it, okay? I invite you to call it something like this. Put it on your desktop, and we're starting making something new now, okay? So I put in the shebang bin bash, the port, right? And then we're going to say echo setting up serial link to Arduino. Okay, put it like that. That's the first thing. And now we need to put in, remember this stuff that we typed before? Okay, it's the stty-f $port, okay? 9600, the baud rate. Dash HUPCL dash echo CS8 CR read, okay, and then we're adding something dash I Conan, not Conan, Canon. Okay, and then min 0 time 10. Okay, that should be right. Let me just check to do port 9600. Yep. CS8 I Canon min 0 time 10. Okay, next. Echo. Reading serial line, and then Q to quit. Okay, now remember there are a bunch of things that you can type, right? You can type a 1, you can type a 0, you can type Q, all those different things, right? So we'll go ahead and set up cases to handle this in the script. While 1, do. read command. Okay, actually, I was premature. While 1, okay, I shouldn't have said what I said because I realized I'm confusing it with something else. See this? What's inside the brackets, you have to evaluate to see if it's true or not. Okay? 1 is considered to always be true. So what this loop is going to do is just keep executing forever. Okay? Because it's saying, is 1 still 1? Yes, it is. Is 1 true? Yes, it is. So just do this. Okay? So we're going to read the command, right? The thing that you type in is coming up next. Now we're going to use the cases. Sorry, I said that wrong before. Case. Remember the case structure. Okay? Case, quote, $command. Quote. In. Okay, that's the syntax, right? And then we start setting up the cases. The first thing that you could type is a 1. Whoops, 1. Okay, so that's the first case. Echo. Turning on LED. Okay? And then, echo, you take the command, okay, and you send it to the port. That's it. That's what you do. The other thing, another thing you can type is 0, right? Turning off LED. Echo, $command, send it to the port. If you want to cut and paste and do this in a more efficient way, you're welcome to do so, okay? Then the other valid thing that you can type is Q. Echo. Exiting. Okay? And then you send that command to the port. Okay? Exit. Okay? Right? Semicolon.
Wait, that's old money.
Did I do some? Money. It's money, yeah. Yep, because we set up port as a variable at the very beginning, up here. That way we don't have to keep typing in dev tty USB 0. And it allows us to maybe change to a different port. You just have to change it up there at the top if that's the case, right? Okay. Then, down here, the other possibility, which is good to put in when you have this case structure set up, is what if it's none of the above? Okay, you get to that one last. You put an asterisk, and then you say echo unknown command. This is if you hit the wrong key or something, right? Okay, and then you don't do anything, and then you end the case structure by typing case backwards, and then done. Okay, now, this script, we can execute this because right now, on this Nano is the code that you wrote, the LED1 sketch is there. Okay, so all you're doing with the script is you're telling it 1, 0, Q, all the stuff that you were doing manually before. It will take those commands and do the appropriate thing, because the code to do the appropriate thing, you've already uploaded it to the board. Okay? So that's all the stuff that we have to type here. So I'm going to go ahead and leave insert mode and then do write. Quit. Okay. Now what I will do here is I will cat the file. Oh, wait, before I do, I'm going to schmod it, right? I have to change it so it's executable. Light, yeah, then I'll do it again. Cat light. Okay, there we go. Doesn't have everything in it, has most of it though. There we go. Okay, we don't need this anymore, right? No, I'm gonna open up another window. Oops, sorry, keep doing that. Okay, open up another window over here, and I would like to execute this. Let me go Control-Shift+++, CD, desktop. Okay, what I would like to do is execute this. See if it will work. Okay. Dot light dot sh. Okay, so now it says reading serial line. Okay, so I'm going to type 1, It's supposed to turn on the LED. Mine is already on, so I don't know if it worked or not, but then we type 0 and it turns it off. Okay, so it's working. 1 again, turn it on. 0, turn it off. Okay, now I'm going to type X. It's going to say unknown command.
Mine just says unknown command.
Unknown command. Okay, you must have something that you, something in your code that's not quite right. Okay? Okay. Okay.
Well, so I have the code right here.
Okay, does anybody need me to look at their code? Are you having trouble with this?
What's the name of the thing? Is this code?
You want that to be on
So like
three spaces.
this each one, yeah.
Give it that space, so you can type on.
Anyone else have any issues?
Okay, are you able to make your light turn on and off using this script? Yes? Okay. Who's your partner? Who's not here? Oh, I'm sorry. Okay, well. You go. Alright, so, you're able to do it. You guys good? You guys good? Yeah?
I want to
Go back to the 10.
Yes?
I feel like it was ordered earlier, but that's gonna be zero.
Okay, to do CHI.
Can I do it?
Yes, because that's where light is, right? Light file.
Light, that's right. Oh, thank you. So light that is a.
Okay.
It doesn't just.
Okay, so the LED sketch, we wrote that so that we could upload it to the Nano, and the Nano would know what to do when you sent it.
So every time you run a
That's
trigger,
the
you have to run
point. The script that
So
you're
what
writing
happens is
now.
when it says like there wasn't a error quite close to this character, so usually it's the it's right after. Yeah. If you research.
Okay, are you using to do this?
Oh.
So you don't want to open it up.
With the one, yeah.
Is this very well?
It works to turn it on, but when it's off.
You have S support.
Oh, she's already got this. Let's go.
So we're gonna see a bash, like it actually there's it really cares about the spaces. Because like otherwise it recognizes like what's the command and what's the argument. You know, and the space is actually what makes the first one, the second one, the third one. Sometimes you need two spaces.
Not positive that it might be still okay, but I was listening.
The thing is like every time that you start a communication, if the other one doesn't work, like it's better to exit communication first and then try to otherwise you're gonna say, oh, your Arduino is not communicating, and then you're gonna unplug, and when you plug it back in, guess what? It's gonna be USB 1.
Oh,
Because like it's gonna keep like taking them like a USB 0 placement on your USB.
Page 0, yep. That's good. Yep. Okay. So scroll. Yeah, that's ESAC. It's the word case backwards.
You know how we have if and then it starts and ends and you say that you start cases with case and you end up in a case with it's goofy, but that's the start. Yeah, right. Once you have that saved, is it here? Is that where it is?
Okay, and so you should be able to type in. Yeah, just type over the
Yeah, if you want to just take this one.
It's so nice.
I gotta do this, so.
That's crazy.
There you go.
I would like to get them. Nothing like this squiggly, this one. I want to do that. I feel like you can do that. I mean, yeah. Because you're like,
I type so slowly, so that's why, I mean, I'm really not very good at them, as you can see, that's why, but I think, well, you know, everybody can keep up with me, hopefully. Maybe can you look at it?
Start chat.
Oh, you're gonna do it.
I think this is his first year.
Oh, I don't know.
oh, yeah.
Okay, so there are several parts to this, what we did today, right? There's the setting up the hardware, right? Okay. And in this case, we use the LED and a resistor to set things up, right? When you look in your bag, you should find an LDR and a thermistor. And let me just remind you what those are. Okay. The LDR is the light-dependent resistor. It's the one that looks like this. It's got legs like this, and it's got this little octagonal thing with looks like a snaky thing on the top. Okay, that's the sensor. That's the light-dependent resistor where the resistance varies depending on how much light you're shining on the top of it. Okay, and it's kind of a pale brown color on top with the two legs sticking straight down. The other one is the thermistor. The thermistor is orange, and it has a silver band across it. That's the temperature-dependent resistor, okay? Again, the resistance of the element changes as the temperature changes, okay? So those are sensors. And when you think about, with your partner, what you want to do for this project, keep in mind that you have both of those available to you, okay? And think about how you might want to use them. So you're going to need to design your circuit so that you can do the data collection. Okay, we can talk more about that next time, or you can come to me and we can talk about like what happens. But you may recall that you're going to have changes. Remember that with the Arduino, what you measure is the voltage, right? The voltage across something, and so the resistance is going to change. The voltage will change proportionally. You can do data collection also, and you can examine the data that you're getting using the serial port with the IDE. But hardware is one of the things, okay, and that's going to inform your design for your project. The other stuff is the sketch, right? So we had this sketch that we used with the Arduino. What did I do with my sketch? I think I just closed it. Oh no, I have it here. Okay, so the sketch, this is the code that you are going to upload to your board, and that's where you tell the Arduino what you want it to do, okay? And so once it's on there, it's there for good, right? Unless you replace it with something else. So that's one of the pieces. And then the other piece is your shell script, okay, where you're going to control it. Rather than typing things in one at a time like we were just doing, right? Where you say, okay, now I'm going to hit the key 0, I'm going to hit the key 1. You could automate the whole thing. Okay, you could set up a script where you say, from 1 to 1,000,000, turn the light on, turn it off, turn it on, turn it off, turn it on, turn it off, right? So you can make, and then you can walk away, right? And meanwhile, it's turning the light on and off, and you're not even there. Okay, so think about what you would like to be able to automate and how you're going to collect information, right? Because that's something you're going to want to do. You're going to want to sample things, okay, and maybe collect data over a long period of time where you're collecting it every hour or collecting it every 10 minutes or whatever it is that you think you want to do. You're going to want to experiment a little bit with what you do too. Usually with the data collection, it's a good idea to do a pilot, right? Do a mini collection just to see how it goes and see how is the data going to look, because you're going to want to plot the data that you collect, okay? So those are the three parts: the hardware, the sketch, and then the shell script. Those are the things you're going to want to think about putting together for your project. We're going to talk about setting up this temperature sensor next time in class on Tuesday, okay? So please make sure that you bring kits with you. If you brought a kit today from last semester, I encourage you to bring it again. It should be that everybody on your team knows how to do this. It shouldn't be that only one person can deal with the hardware. Everybody should know, okay? That's part of what we want to get out of this, but also it means that if something happens, like one of you gets sick or something like that, you'll still be able to complete the project because both of you will know how to do stuff, okay? Does anybody have any questions on this? Yeah?
For the data collection, are we collecting both like light and sound, or turning on LED?
Maybe.
Okay.
Temperature, actually, I think temperature is what the assignment is. You could use light if you wanted to, but the assignment is for temperature. So you at least do temperature, but you could include light if you wished. I'm just pointing out that you have that sensor available as well, okay? Any other questions? No? All right, so I'll see you guys Tuesday. Let me just... Yeah.